Okay, guys, so today we're going to talk about something called a system of linear equations. So the first thing we're going to go over some vocabulary. So a system of equations is really just two or more linear equations that are kind of grouped together. And then the solution of a system of linear equations is an ordered pair that makes all of the equations in the system true. So there are three types of solutions. So the first one we see right here, and that is an intersection. So if where the lines intersect is a solution, so like right here, this would be whatever point this is, -2, 2. That would be our solution. The other thing you can get is no solutions. So when we move into graphing, what that means is your lines would be parallel and there would be no point of intersection. That would make that true. And then the last thing you could get is infinite solutions. And that is where when you graph it, you get the same line. So while we can use graphing to solve these, there are other ways to use as well. So the first thing we're going to talk about is the equal values method. And so we have a system right here. You notice we have two equations that are kind of grouped together. Sometimes they'll just be listed like that. Other times they will have a bracket like this next to them. I write them using the bracket. Some people do. Some people don't. Either way, it's fine. So with the equal value method, what we would do is we would set these equations equal to each other. So here, I have -2x plus 22 is equal to 3x minus 28. So all I did was take this equation and this equation and make them equal to each other. So then I will I'll add 2x to both sides to cancel this out right here, which would leave me with 22. And then 3x plus 2x is 5x. Then I'm going to add 28 to both sides to cancel this out right here, which would give me 50 is equal to 5x. And then I would divide by 5 on both sides to get 10 is equal to x. So the thing with this is now we also have to solve for y. So I'm going to use my second equation right here. And I'm going to plug in my solution for x that I got right here. And so I'm going to do y is equal to 3x, which in this case is 10. So 3 times 10 minus 28. That'll give me y is equal to 30 minus 28. And I know that y is 2. So if y is 2 and x is 10, my point is 10, 2. So that is where those lines intersect. So let's do one together. So I have y is equal to x plus 2, and y is equal to 4x plus 23. So I do x plus 2 is equal to 4x plus 23. And I'm going to go ahead and draw my line because I'm going to solve for x on one side and y on the other. So I'm going to go ahead and subtract x from both sides. And that's going to give me 2 is equal to 3x plus 23. Now I'm going to subtract 23 from both sides. And that will give me -21 is equal to 3x. I'll divide by 3 on both sides to get -7 is equal to x. So now I'm going to solve for y. So I'm going to use this equation right here. So I'm going to say y is equal to -7 plus 2. And that will give me y is equal to -5. So if -7 is x and -5 is y, I have the point -7, -5. We're going to go over here and do another one. So as you can see, I have 3x minus 22 and 2x minus 15. So same thing. I'm going to set these equal to each other. I'm going to subtract 3x from both sides. Which will give me negative 22 is equal to negative x minus 15. I will add 15 to both sides. To get negative 7 is equal to negative x. I'll divide by negative 1 on both sides. And this will give me 7 is equal to x. So if 7 is equal to x, I'm going to use this equation right here. And I'm going to plug that in for x. So I'll say y is equal to 2 times 7 minus 15, which will give me y is equal to 14 minus 15, which gives me y is equal to negative 1. So if x is 7 and y is negative 1, I get the point 7, negative 1. So when you do these, it's really important to remember that you're just applying what you already know from two-step equations. So everything I'm doing over here on this side is just using inverse operations, okay? So we're always going to start by moving that x over to the right side every single time. That's always your first step. And then once you do that, you have a two-step equation that you know how to solve. So we're going to do 2 more. So same thing. Here I have y is equal to 4x plus 24 and y is equal to x plus 9. So I'm going to say 4x plus 24 is equal to x plus 9. And I'll go ahead and draw my line. And I just am doing that to keep my work separate. That's just an organizational thing. You don't have to do that. So the first thing I'm going to do is subtract 4x from both sides. Which will give me 24 is equal to negative 3x plus 9. Now all we have is a two-step equation. So I'm going to subtract 9 from both sides. And this will give me 15 is equal to negative 3x. So I'll divide by negative 3 on both sides. To get negative 5 is equal to x. So then I'm going to use this equation right here and plug my x value in. So y is equal to x plus 9. So negative 5 plus 9. That would make y equal to 4. So from there, if x is equal to negative 5 and y is equal to 4, that point of intersection is negative 5, 4. Over here, I have y is equal to 5x plus 20, and y is equal to x plus 4. So I'm going to set 5x plus 20 equal to x plus 4. So I'm going to go ahead and subtract 5x from both sides. And that gives me 20 is equal to negative 4x plus 4. I'm going to subtract 4 from both sides. And that will give me 16 is equal to negative 4x. And then I'll divide by negative 4 on both sides. And that will give me negative 4 is equal to x. So I'm going to use this equation right here. So I'm going to say y is equal to x plus 4, so negative 4 plus 4. That gives me y is equal to 0. So if x is negative 4 and y is 0, I have the point negative 4, comma 0. So down here, I have negative 6x minus 14 and negative 5x minus 12. So we're going to do the same thing, set those equal to each other. And then leave room to solve for y. So I'm going to add 6x to both sides to undo that negative. That'll give me negative 14 is equal to x minus 12. I'm going to add 12 to both sides. And I will get that negative 2 is equal to x. So now I'm just going to plug that into this equation right here. So I'll have y is equal to negative 6 times x, which in this case is negative 2, minus 14. So this is going to be y is equal to 12 minus 14, or y is equal to negative 2. So here, x is negative 2 and y is negative 2. So we have the point negative 2, comma, negative 2. Over here, I have negative 6x plus 18. And that will be equal to y is equal to negative 3x, or sorry, just 3x minus 9. So I'm going to go ahead and add 6x to both sides. And that will give me that 18 is equal to 9x minus 9. I'll add 9 to both sides. And this will give me that 27 is equal to 9x. I'm going to divide by 9 on both sides, and that will give me that 3 is equal to x. So here, I'm going to use this equation. So I will say y is equal to 3x, which in this case is 3, minus 9. So I get y is equal to 3 times 3 minus 9, which is 9 minus 9. So y is equal to 0. So this is the point 3, 0. So now we're going to do 4-word problems. So here it says a gym on Bardstown Road has an initial joining fee of $210 and a monthly membership due of $15. So I'm going to go ahead and say that Y is going to equal cost and M will equal months. So to write an equation for the Bardstown Road gym, I'm going to say that the cost is equal to the $15 times the number of months plus that joining fee of $210 because they only had to pay that one time. So a gym on Preston Highway has an initial joining fee of $120 and a monthly membership of $25. So here the cost there is going to be $25 times the number of months plus that joining fee of $120. So this right here is your system of equations. So it says, when will the cost of the two gyms be the same? So here we're solving for how many months it's going to take for the gyms to be the same. So I'm going to do the same thing we've been doing and set 15M plus 120 equal to 25M plus 200. Oh, I wrote that backwards. Whoopsie. This should be 210. Plus 120. And we're going to figure out M, because whatever we get here for M will tell us that month where the cost is the same. So I'm going to go ahead and subtract 15M from both sides. And I'll get that 210 is equal to 10M plus 120. And then I'm going to subtract 120 from both sides because I'm just solving this like a two-step equation. And I'll get 90 is equal to 10M. From there, I'm going to divide by 10 on both sides. And I see that 9 is equal to M. So it will be the same at 9 months. Okay. So here it says it's the end of the semester and the clubs at school are recording their profits. The science club started out with $20 and has increased its balance by $10 per week. The math club saved $5 per week and they started out with $50. So I'm going to say that Y is the savings. And W will represent the weeks. So here, I'm going to erase all the stuff from this first problem so we've got some room. So here, the science club started out with $20 and increased by 10 per week. So I'm going to say that Y is equal to $10 times the number of weeks plus that 20 that they started out with. For the math club, their equation, I'm going to say that Y is equal to $5 times the number of weeks plus the $50 that they had to start out with. So we have our system of equations here, and it says, when do the clubs have the same balance? So we're trying to figure out that number of weeks. So I'm going to set 10W plus 20 equal to 5W plus 50. So I'm going to subtract 10W from both sides. To get 20 is equal to negative 5W plus 50. From here, I'm going to subtract 50 from both sides. And that will give me negative 30 is equal to negative 5W. And I will divide by negative 5 on both sides. And that will show me that 6 is equal to W. So they will have the same amount of money after 6 weeks. On our next problem, we're dealing with changing populations. So it says, Post Falls School in Idaho has 11,600 students and is growing by 22 students per year. Richmond High School has 1,900 students and is shrinking by 15 students per year. And what we're looking for here is when the schools will have an equal number of students. So I'm going to say that Y is equal to population and that T is equal to years or time. So for Post Falls, I know that Y, or my population, is equal to 22 times the years plus that 11,000 or 1,160 they already have. For Richmond High School, I know that Y is equal to negative 15 times the number of years. And the reason it's a negative 15 is because it is shrinking. Okay? Plus that original 1,900 that they start with. So we are going to use these two equations to figure out how many years it will take for their populations to be the same. So I'm going to set 22T plus 1160 equal to negative 15T plus 1,900. So from here, I'm going to subtract 22T from both sides. And this is going to give me 1160 is equal to negative 37T plus 1,900. From here, I'm going to subtract 1,900 from both sides. And that is going to give me negative 740 is equal to negative 37T. So I'm going to divide by negative 37 on both sides. And this will give me 20 is equal to T. So 20 years is when they will have the same population. So down here it says that Barbara has a bunny that weighs 5 pounds and gains 3 pounds per year. Her cat weighs 19 pounds and gains 1 pound per year. When will the bunny and the cat weigh the same? So here, the bunny we know, So I'm going to say that y is equal to their weight, and that t is equal to the years. So I know that the bunny's weight, so y, is going to be equal to 3 times the number of years plus the 5 pounds we started with. And then the cat is going, the cat's weight, which is also y, will equal 1 times the number of years, so just the number of years, plus the 19 pounds that he weighs now. So I'm going to set 3t plus 5 equal to t plus 19. So I'm going to subtract 3t from both sides. And that will give me 5 is equal to negative 2t plus 19. So now I'm going to subtract 19 from both sides. And that will give me negative 14 is equal to negative 2t. I'll divide by negative 2 on both sides to get that 7 is equal to t. So they will be the same weight after 7 years.